Hello, I'm K.R. Zentner, and in this video I'm presenting a simple approach to continual learning by transferring skill parameters. We explore how effective a very simple approach to continual learning can be. After learning each task, we only retain the parameters of the policy that solved that task. Furthermore, we only use on-policy deep reinforcement learning without specialized neural architectures. Despite these limitations, we show how efficient continual learning is possible if the order of tasks can be controlled. The experiments we present in this work use tasks from the MetaWorld MT10 benchmark. However, unlike the traditional application of MT10, we only require access to a single environment in MT10 at a time. Our basic building block in this method is to repeatedly apply a slightly modified proximal policy optimization. We add a step at the start of training each task where we train the value function before adapting the policy. This prevents valuable behavior from being lost due to high variance advantage estimates. We also make use of a rejection rule that restarts training if it gets stuck in order to allow reliably solving many tasks in sequence. We apply this basic building block naively to each pair of tasks to determine the potential speedup for transferring from each possible base task to each possible target task. Then, we interpret the resulting training costs as edge weights in a graph and extract its directed minimum spanning tree. This gives us a tree which describes the predicted optimal order to learn all tasks in. Then, we attempt to learn all tasks by transferring parameters along the edges of the tree. However, during training some edges may be rejected. When that occurs, we remove rejected edges and resolve for a new curriculum consistent with the tasks solved so far and continue learning. We are able to extract many curricula using this method, and find that using a near-optimal curriculum is necessary to learn more efficiently than learning each task from scratch. In the best case, we are able to learn all tasks approximately 30% more efficiently than from scratch. Here's an example of one series of transfers used in the optimal curriculum for MT10. First, pick and place is learned from scratch. Then, that pick and place policy is adapted to quickly solve push. Finally, the resulting push policy is used to learn peg insert side. Although its initial success rate is extremely low, it learns much faster than training peg insert side from scratch. In this run, attempting to learn drawer open using the window open policy became stuck in a local optima. The rejection rule detected this, and so the next best base policy, pick place, was used instead to successfully learn drawer open. Thank you for listening.